In this video, we'll demonstrate the benefits of adaptive impedance matching to wirelessly power multiple receivers. First, adaptive impedance matching is disabled, so the system only controls the frequency and power level of the transmitter. When the user presses apply, the rectified voltage at each receiver is shown in the plot. All receivers are programmed to charge the battery at 75 milliamps. The blue LED indicates that wireless power is active and the battery is charging at the full charge current. Without adaptive impedance matching, certain receivers receive more power than others, so not all receivers are fully powered. As the receivers move around, some configurations allow for all 4 receivers to be sufficiently powered, but in general the system is not stable across 4 receivers. When a 5th receiver, which does not have a battery connected, so the load power will be much less than the other 4, comes into the system, the power delivery is even more uneven, and now the 2 leftmost receivers are not receiving sufficient power. With adaptive impedance matching enabled, we repeat this experiment. Upon pressing apply, each receiver individually tunes the matching network at the input to the rectifier to balance the power received. After a few seconds, the system stabilizes, and adaptive impedance matching pauses until the receivers are moved around again. Any given receiver should not consume too much power, which takes power away from other receivers that might need it, but also maintains sufficient power to charge the battery at full charge current. As the receivers move around, adaptive impedance matching restabilizes the system very quickly. This time when a 5th receiver with lower load power requirements comes into the system, the 5 receivers are all sufficiently powered. It takes a few seconds longer for the system to stabilize, but eventually all receivers, even those with different load power levels, are powered, and the system is stable until all batteries are charged, or until the user presses stop.